Testing the audio. Hello. Can everybody hear me?
Hello, yes, can hear you. Hi.
Oh. Are you waiting for the chairs?
I think so.
So are we expecting any of the chairs, or are they both not able to make it this time?
I think we could just Paul, just discuss updates maybe, and maybe talk about what we plan to do at San Francisco.
Sounds good.
Yeah, sounds good. Yeah.
Should I go first?
Well, I can go first, as I have a small update on the vocabulary document.
Go for it.
It's pretty quick. We can get our agenda. So at the moment, I'm working on making the vocabulary document into a draft on the way we discussed in one of the previous meetings. So it's going to be a separate item rather than just an appendix on one of the other drafts. And as soon as I'm done, at the moment I'm struggling a bit with the XML drafting process. But as soon as I'm done, I will send an email on the mailing list for review. And yeah, feel free to add any contributions to it. But that's about it. So I expect an update on the vocabulary in the next couple of days to the mailing list. That's all I have.
Yeah. Any questions for Alex? Going. Okay. Thank you, Alex. Okay. Should I go next, or Rama? Did you want to go next?
Just minor updates for me. I added small amount of text on addressing the comparison between SATP and ISO 20022 in the for the architecture draft. I just shared that privately with you, Thomas. But if I can,
Okay.
if you can share that on the meeting list.
Yep.
So, what do you suggest?
Yep. thank you. I received it. I'm going to work on it today, but I just realized the cutoff date for uploads of drafts was yesterday. So there's a kind of moratorium until, I guess, the Monday of the ITF. But I
Oh, I
think
thought
it's
15th, wasn't it?
I thought it was yesterday. Yeah,
Yes, it was.
somebody check the website.
No, it was yesterday. The cutoff has happened. So for now, until the IETF starts, there's no more updated drafts.
Okay, so that's fine. So Rama, I'll try to upload it like the Monday of that week, so that but I don't think it's significant changes. It's more like, we've added text on the ISO and we understand. And it's interesting, folks. Actually, if you guys are interested, the BIS, Bank of International Settlement, has just published their I think annual or 6-monthly report, and there's a particular section on this, related to this problem, and the fact that the current messaging scheme, I mean, even they recognize that the current ISO messaging is not enough, that you can't do tokenization with just messaging. So we can if people are interested, send me email. I'll send you the link to the PDF. I'll send you the PDF altogether and you can have fun reading it. But so I think we're on the right track, I think, is what I'm trying to say. Okay, thank you, Rama. Anything else?
Oh, yeah, I have to push an update to the use cases draft as well, but I guess I missed the deadline. Anyway, I'll do it by on the Monday of the.
Yep. Okay, great, thank you. Rafael, let me go first, and then when we get to the section on session resumption, maybe you can jump in.
Yeah, sounds good.
Okay, now, folks, I'm going to try and share my screen, which is the version 19 of the message flow, which is on the GitHub repo. And let me hang on. How do I actually share my screen? Actually, you know what? Maybe it's easier if everyone just goes to the repo. Maybe somebody can post the link to the repo and look at the diagram. And I'm asking a lot, just look at the diagram. If you really want to, you can also open SAT core, which is a match now with the diagram, minus some 1-2 words that are erroneous. So if you look at version 19 of our color message flow diagram, you will see that the transfer commence message and the acknowledgement for that message has been moved up to stage 1. So that's sort of the first big change. And so the reason being was that, as Alex pointed out correctly, it was kind of awkward to look at this transfer commence in stage 2, when really the purpose of stage 2 was to do the locking and to deliver the assertion for the locking. And so, logically, in terms of functional grouping, yes, it makes sense to exclusively focus stage 2 on just the lock and the lock assertion. And therefore, it also kind of makes sense that all the preparation and all the agreement to proceed between G1 and G2 really need to happen in stage 1. So if you look at that diagram, and if you look at SAT core version 02, which I updated 2 days ago, you'll see now there's a transfer proposal claims section. So that is basically putting together all the information that G1 and G2 need to agree upon in a set of proposal claims. So that includes, if you look at the SAT core, that includes things like Alice's verified identity, Bob's verified identity, Alice's address, Bob's address. So imagine if you had to move this, regulated asset This is the kind of set of information that G1 and G2 as the owners and operators of the gateways will need, right? So that's, I think, is now section 7.1 on the SAT core draft 02. And the diagram, the color flow shows a dotted circle. So basically, this is a multi. It could be a multi-round negotiation. So G1 says to G2, "Hey, here's the set of claims that I think you can accept," and G2 might say, "Well, hang on a second. You've got the wrong address for Bob on my network." So that's message 1.2 and goes back again. So it's a loop. And if you are interested in deep down again, so the actual messaging start in section 7.3. You know what? Let me open up. Actually, here it is. So if you look at section 7.1, that's all the claims pertaining to the asset. And I added a new section 0.2, which is all about the network capabilities. So this is the stuff we have discussed in the past, such as, well, what locking mechanism is being used in network 1? How long is the standard average lock duration in? So 7.2 is really network specific, and G1 and G2 are talking about their own networks. And so the logical separation of the asset-related claims and the network-specific information or network capabilities claims is 7.1 and 7.2. And so really the flows start in 7.3, 7.4 is the loop, and 7.5 and 7.6 is just a way to G2 to say accept or reject. So if G2 says, okay, I like the claims that you've just sent me and I wish to proceed, then G2 has to explicitly do an acceptance message, right? So this would be 7.4, transfer proposal receipt message. So G2 has to include a hash of the set of claims and say, yes, I accept this. And this has to be explicit. Now, one way that I've introduced in 7.5 to actually do the loop thing, and feel free to improve on 7.5 because there might be better mechanisms to do this. If G2 says, okay, you've got everything correct 90%, but I want these things updated or modified, then G2 will send a conditional reject. It's conditional, and here's a set of alternative claims that I am proposing. So it's a counter proposal, and the text talks about a counter proposal. So counter proposal, and then back again, here's a updated repeat, transfer proposal message. So this loop. Now, if G2 says, okay, I'm good to go, then he's going to say explicitly proposal receipt message is digitally signed. If G2 decides to give up, okay, I'm tired, I want to go away, and you go away, G1, it's going to send a transfer proposal reject, which is the same structure except the proposal field is blank. There's nothing in it. So it signals to G1 that G2 is giving up and terminates session. And this is where the errors messages section down below makes sense, because this is a graceful termination. It's not a protocol error. It's G2 saying, I want to quit. So that's section 7.5. And if everything is good, then we're back to the flow diagram, which is transfer commence and acknowledgement of the commence, which is 7.6 and 7.7. So that's kind of the progress that we made. And this came basically from a side discussion that a group of us made a couple of weeks ago, on a separate Zoom call, which I think was announced, and there were 5-6 of us, and we talked about this, and this is stage 1. Any questions about stage 1?
Hey, sorry, quick clarification. So one thing, shouldn't we name 1.2 as transfer proposal acceptance rather than receipt? Because I think receipt will happen at every step of the negotiation, right?
Yeah, agree. Yeah, we can fix that. I use receipt because down below in section 3 we use the word receipt. But yeah, yes, accept. I know. In fact, I had acceptance. I was like, okay, let's just be consistent. But I mean, I like the word acceptance better. But yeah, good.
But one more thing about how the gateways should actually negotiate this. I mean, if a gateway gets a counter proposal, we are not saying how it should handle the counter proposal, right? And whether it should decide by itself whether to accept the counter proposal, reject it, or should go back to the network. We are not saying that. That's we're taking that as
Correct. It's out of scope for us. And in fact, this is part of the discussion that I think Dennis wants to have about the context. This is the application to application thing, right? That really the application is already knows which asset and asset type and so on. And I think Dennis's point was that the proposal needs to include the asset profile ID. It's just the ID number of the JSON document that defines the asset. So there's that, and then there's the actual assets itself in network 1, which has its own identifier, right? But all of that is the context that needs to happen, which is now out of scope, currently out of scope for us.
Okay. Just one some bit of background material on that. I mean, I did some work back in a PhD on this kind of negotiation, and it was based on the two sides having their own policy databases. And when you get a counter proposal, you match it against your policy, see if it's accepted, and or whether you need to send a counter proposal. And also, there's work done in the grid computing on service level agreements. So this is kind of you can borrow from that.
Yeah. So Ramo, anyone, if you have a better idea of how to express this loop, proposal, accept, reject, if you have better mechanisms, feel free, to suggest, because that text there in section point 7.3 proposal, 7.4 the receipt acceptance, and 7.5, yeah, that's fluid right now. We can change that. It's just a way of saying, well, if somebody asks us, well, how do you do this this loop thing, right? Which I think, to be honest, I did not look at how IPsec or how Ike version 1 did it, or Ike version 2 does it. But it's the same kind of model that in Ike, there's a security policy database at both ends, and they keep on looping. And I think one of the biggest thing is, like, for example, negotiating the algorithm for the hash, right? So yes, we assume we today conveniently say, oh, we'll just use whatever NIST says, right? But it could be that specific networks have a different, maybe stronger standard, beyond NIST, and so we need some kind of a way, for example, to identify the hash algorithm IDs, which is already standard, right? So that we have to communicate that. Yeah, but yeah, Rama, if you have any alternative ways to do this loop, yeah, happy for you to recommend it.
Sure.
Any questions about that particular the stage 1 changes? Anyone? No. Okay. Okay, so going further down in the diagram, in the flow diagram version 19. So at our, I think, last interim meeting, and also subsequently on the email, Alex pointed out something, very, very observant, very good, which is that it seems that in the old previous diagram, the acknowledgement prepare message was redundant. Like, why is it there, right? So if you look at stage 3 now, we have a commit prepare 3.1 that basically signals G1 to G2, get ready. I've agreed on the lock assertion that you have, and I've indicated I've accepted it. I'm accepting it, and I'm giving you a signed receipt. And so now G1 says, okay, let's begin to prepare to commit. And this is the classic commit prepare message that we've stolen from the database world. Now the act prepare, for those who don't know, so the original 2-phase commit, 3-phase commit in the database was a one coordinated database to many n recipient databases. And so if you had like 3 databases on the other side, then the coordinator, which is in our case is G1, it needed to receive an explicit acknowledgement from all 3, and that's your act prepare. But since we only have one recipient gateway, so it's only G1 and G2, it's kind of redundant. And so in this diagram, the act prepare has been grayed out. And so for those who've seen multiple versions of this diagram, what will happen is that it's grayed out to tell you that when we update this diagram next time to version 20, that is going to be completely gone. The grayed out is just going to be deleted. And as if you guys are keen enough, you can see all the previous versions going back to I think version 7 was the sort of the most it had feet, let's just say. You'll see the same thing, things grayed out, and then suddenly at the next rev it's deleted. So that's the first major change for stage 3. We do not have an act prepare, and I have explicitly, if you go to the top of the diagram, you'll see IETF-SATP message flow diagram, asset transfer, unidirectional, one sender, one receiver. Okay, and the message we're trying to say to people that, okay, we're conscious that there's only one sender gateway G1 and one receiver G2. And if people have, in the future, ideas about, one-to-many asset transfers, great, you will need this act prepare, you bring it back into the picture, if you need it. But for now, that's out of scope for SATP. We're just doing unidirectional one-to-one. So that's probably the only major change. Minor typo. So if you look at the blue message 3.5 blue balloon on the right hand side, I said 3.5 must be received by G2, else G1 may be subject to the classic heuristic deadlock state. So we had a discussion led by Dennis about the fact that even in today's databases, in the 30-year-old field, well-studied, well-documented, mature products and so on, there might be very edge cases where it's not a deadlock. Deadlock is too strong a word. That the protocol gets into an awkward and a stuck state. Right, deadlock is too strong, and so the message, the key, takeaway from this is that we really need to have transport reliability for 3.5. So 3.5 has to be received by G2, right? And so in the case that G2 dies, crashes, and 3.5 goes unanswered, what will happen is that the asset has been extinguished in network 1, but in network 2, it's been self-assigned to G2, so G2 still owns it, but Bob hasn't received it. Right, so this is an awkward. It's an awkward state. It's gone. It's been recreated. Yes, it is in network 2, but it's on the wrong owner. G2 is the owner, and not Bob, and so it may need manual intervention in the sense that Bob knows this is coming. This asset is coming because Bob's application is waiting for it, but it's still stuck at G2. And let's say G2 crashes, G2 needs boot up and say, okay, this asset is self-assigned to me, but it really needs to be assigned to Bob. And so then G2 needs to assign this in 3.6a to Bob. So the AI for me is to remove the word deadlock from the document and also from this diagram, because it's the wrong word. It's just it's called a heuristic state, and it's kind of a very specialized terminology that the database people use. Go ahead, Rama.
Particle matter. I wonder if we can handle this heuristic state using the timeout. So we have G1 has committed to sending 3.5, right? Assuming it's able to carry out section 3. Step 3.5 extinguish. If it does that, then assuming both G1 and G2 are complying and neither of them is behaving in a Byzantine manner, then G1 commits to sending 3.5. So if it cannot send 3.5, then in one go it will keep retrying. So then G2, if it does not get 3.5 within a particular timeout, it can probably just give up. And if G1, if they can choose to follow the protocol. So if G1 fails to send 3.5 in a way that it knows has reached G2, and the timeout is passed, it knows that its extinguish should be reverted, and G2 knows that it should not proceed. So that's something they could do. But of course, it's there are many different kind of cases protocols they can follow here.
That's right. So the point of this is to communicate to the reader that we are aware of this very edge cases, right? It's almost a contradiction, because we've said from the beginning we have to have transport reliability. So 3.5, G1 can resend 3.5 multiple times, right, until G2 receives. And so this is part of the crash recovery, that G2 or G2 backup needs to understand that it's waking up from a crash state. And so if we, number one, if we remove the case of message lost, no, messages do not get lost today. I mean, none of my Netflix movies ever get lost. The internet is so reliable. So assuming we say it's got reliability, then really it's G2 crashing that is the issue. Oh, of course, we could have a DOS attack. So a DOS attacker could be monitoring this and say, okay, at the right point, we're gonna, flood, G2 with all these messages to make it, dysfunctional, basically. But yeah, so this is also part of the session resumption that we need to handle, and Raphael can talk about that maybe after this, but in the draft the core SAT version 2, there is a new section on session resumption, and we've been having some issues with the diagram. So there is a missing diagram in the text, but there is a new section there, if you look, which is now section 10, called session resumption. So Raphael is proposing to use the primary backup model as the model. It's the easiest model. It's true, this primary backup. And so primary backup is configured to understand the current state before G2 actually crashes. So G2 prime knows how to pick up. Okay, so maybe that's a good segue. Actually, any questions for me before I hand over to Raphael? Okay, Raphael, all yours.
Thanks, Thomas. Yes, so we've been working a bit on the session resumption. So this is also joint work with André Augusto, which is on the call. He did an excellent implementation of this functionality in our open source implementation of SAT-P at Hyperledger Cacti. So this corresponds to, in the SAT-P draft, section 10, I believe. Exactly, 10. In section 10, we are referring to the crash recovery draft for a more detailed overview of how we do the logging and therefore are able to capture the state at every point in the process. In the core draft, we are giving considerations on how to do the recovery itself. So the recovery itself, it's based on a rather simple primary backup mechanism that Andrea, August, and I studied a while ago, where each gateway on the setup phase defines a list of backup gateways. So in the form of public keys that can be encoded in X509 certificates. So upon crash, the counterparty gateway will wait for a certain timeout, which we call the max timeout. And it will basically either wait for normal messages of the protocol or for a recover message. If the gateway recovers, if the gateway receives a recover message, it means that the counterparty gateway crashed and was able to recover before the max timeout. If the max timeout expires, then the counterparty gateway initiates a rollback procedure. So we introduce the rollback procedure when the crash seems permanent, or when it's sensitive to issue a rollback instead of waiting even more for the crashed gateway to recover. So the crash gateway, we can assume that it recovers by itself, called the self-healing, but we focus on the primary backup mechanism because it's probably more reliable, and we can also add parallelization, making it more efficient. So in this primary backup mechanism, the crashed gateway is replaced by one of the backup gateways that were accorded in the beginning with the counterparty gateway. Such gateway, one of them, identifies itself to the counterparty gateway that didn't crash, and they can resume the process from there. We defined a few messages for that information flow to be exchanged, which is the recover update, and recover success messages. So when a crashed gateway recovers, it sends a recover message to the counterparty gateway. It informs the counterparty gateway of its most recent state, the specific certificate information that the counterparty needs to verify the identity of this new gateway, because note that the recovered gateway is a backup gateway. It's not the original gateway. So the session needs to be, a new session needs to be created between those gateways, TLS sessions, etc. After that, the counterparty gateway sends back a recover update message, which also informs the latest state of that gateway. So the recovered gateway can compute let's say, the aligned state after the crashes. So there's a computation step which computes the latest state after the crash. And after the crashed gateway, now the recovered gateway computes the latest state, then it sends the recover success message, and both gateways at this point are agreeing on the same state after the crash, so that they can resume the SATP process. So this is the underlying idea. We'll still have to add a few drafts. We had some formatting issues. Hopefully we'll resolve this soon. And adding a bit more details about these techniques. So they're quite well documented, or rather documented in detail, in an academic paper that Andrea Augusto led. But we need to port some of those details to this document, and also the crash recovery document. So that's what we've been doing in the last few weeks. Any questions?
So Rafael, the plan is for you to be presenting in San Francisco, right? You're gonna, he's got slides. let's just say. So we have probably a more extensive discussion about this.
Yes.
And probably it's worth explaining to folks who are not following this closely, the mechanism to actually recover and so on currently is out of scope, right? It's the thing that is scope is the arrows in between the two columns. But like the context setup discussion, we need the core to be informed by at least some, we need some crash recovery scheme or architecture that informs SAT core. And so Raphael's picked one, which is the easiest one, which is primary backup, right? But if you are interested, I know Raphael and Andre, they have papers, academic papers that talk about all sorts of kinds of other schemes, paradigm schemes to do recovery for gateways.
Just clarifying. So you plan to write this in a separate draft, or you plan to add this to the core draft?
There is a section so when we talk about session resumption in section 10, again, it's the first text you have that, so the idea would be there's a G2 would wake up, or G2 backup, G2 prime will wake up and say, hey, I want to resume. And so the question is, what does G2 backup tell G1 in that resume message? So there's at least, we've identified like 3 possible flags, which is in capital letters there in section 10, which is recover, update, and then the response will be recover, success. Right. So yeah. We're limited in the current scope to just have 2 messages that can also loop around, right? There's the I want to resume request, and then G1 will say, okay, yes, let's resume. Because G1 can say, okay, hey, you've been silent for 60 seconds. I'm giving up, right? That will also be the default behavior of G1, right? This is, worst case scenario, G1 is, but is there a way for us to inbuild just a simple message sort of 2 message or 3 message addition that we can ideally insert anywhere in the flow, so it doesn't, it could crash, for example, looking at it could crash in stage, stage 2 when the lock assertion message was sent by G1 crashes. Can we use the same pair of session resume request and request, granted, anywhere there? That's kind of the goal. I don't know if it's achievable, but I think that was the thing that I think Raphael is trying to communicate. But what that message contains, that's the TBD. And I think knowing more would require. There is a separate draft there. Raphael's got a new draft uploaded, and that will inform us. Well, what should be the body of the session resume request message, the fields?
Yes. So we basically we say that there are some interfaces to do this process in the core, but the core isn't normative about what to implement. And the crash recovery draft suggests an implementation, or a specification rather, of that crash recovery mechanism.
But crash recovery should, I think, can still be in the present scope, right? I mean, SATP scope seems to cover the entire process of moving an asset from one network to the other.
So the formal answer is, let's finish the first 3 drafts that we have before we add more. But it doesn't mean that we should not continue working. And I've said to Raphael, like if I understand correctly, and there's plenty of experienced people here, from the IETF, that they should continue working on the draft because at some point it will become relevant, and there might be sufficient reason after the 3 is finished to actually adopt, the crash recovery, for example, as a proper formal working group item. And the same, Rama, with the views, right? Which is why I was asking you, the views thing is actually absolutely needed, right? So this discussion about tokenized deposits. This is about representing your bank deposits, which is what the BIS people are talking about. Bank of International Settlements as tokens on a ledger, that's a private network, right? And so if I want to sell my Ferrari to you, not that I own a Ferrari, I need some proof that you have liquidity, right? And for those who are following the whole FTX thing and Terra Luna, liquidity is a huge topic. I mean, both these, particularly Terra Luna, Terra USD and Luna, it was the lack of proof of liquidity that just brought the whole thing crashing, right? So proof of liquidity would need to be something like what you have in the views, which is this: here's my proof. What's the network ID? What's the block ID? What's the transaction ID? Right? Which is what you already have there in the snippet that you gave us on the mailing list, Rama. Okay. Thank you, Rafa. Anyone got any questions about this topic? Okay.
Not on this topic, but going back to the message diagram, I'm still wondering where in this whole process does the asset move from G1 to G2?
Right. So it's a burn. So David, it's a burn and mint model. So formally speaking, by the time we reach message 3.7, formally the asset has moved.
When when do the bits in the asset actually move from G1 to G2? That's going to have an effect. We're talking about recovery. We're talking about resumption.
Yeah. So in the burn and mint model, it's not like transferring bytes, as in using something like SRTP or something like that to do reliable transfer. It's burn and mint. You destroy it and regenerate it, and the model doesn't necessarily work for every single type of asset on the planet, right? So somebody could argue that for CBDCs it doesn't work, but Alex, did you want to speak up?
Yes, I only wanted to add that according to the SATP model, the asset moves at the point, I guess, when it's deleted from the initial network. But you will notice, according to the diagram, that the asset is present in both gateways at some point. So because this is the way the mint and burn model works. First, we created in the account of the second gateway, and only after we are certain that this asset now exists on the second network assigned to the second gateway, then we burn it. So essentially there will be two representations of the asset present at one point, but we can consider that once it's deleted from the initial network, that's when the move effectively happens.
Thank you, Alex. Any other questions before I want to say one suggestion for the people going to the San Francisco IETF. So right now we're listed SATP to be meeting on the Tuesday morning. And so for those who are going to be in San Francisco, I was thinking that maybe we could get together for lunch. And we certainly want to invite the ADs.
It's Thursday morning.
Tuesday morning or Thursday morning?
Thursday.
Oh, they moved it. Okay.
No, it was always on Thursday, 27th. That's what I saw. Yeah.
Okay. Whatever morning is, don't go away for the lunch. Hang around, and we can all get together and get lunch. And we want to extend an invitation to Paul, of course, who's been tremendous helping us here. So, Paul, if you're around, we could shout you lunch. I don't know if ADs are allowed to drink beer at lunchtime, but yeah, the beer is also available.
Okay, looks like they changed it. You're right. It's not Tuesday, but it was Thursday until a couple of weeks ago. So you're right. Tuesday 25th.
Okay. And anything else, folks? Any questions, issues, concerns, ideas, proposed, new work items, things you guys want to work on,
Nothing from me.
All good.
Quick mention that we have so under Hyperledger, we have the Cacti project, right? Doing interoperability. So Hyperledger organizes a mentorship program every year, which and they pay people, and people can apply to work on particular features. And so we offered a project to implement SATP within Cacti using the relay component. The relays being like gateway components. So just wanted to let everybody know that we have an active implementation of that going on. And I asked the intern to be on these calls as much as possible. He's on vacation right now, but as any feedback that we get when it comes to how easy it is to implement SATP, or if there's something we missed out, then I'll communicate that in these meetings or on the mailing list. So there's something that Rafael and I are leading.
Okay, good. Cool. Thank you, Rama. Any questions for Rama? Oh, okay, folks. So hearing nothing, I think we want to give back 9 minutes to everyone's calendar. So I hope we see as many as possible you guys in San Francisco. And yeah, just put that in your calendar, the Tuesday morning and Tuesday lunch for our group. Okay, folks. So I don't know how to actually end this session. Maybe Paul, you need to actually click a button somewhere to end this session, the actual Meet Echo. But I think if people just log off, Meet Echo will probably terminate itself.
Yeah, I don't have any special permissions either, as far as I can tell. So we'll just all leave and hopefully it'll work.
Okay. All right. Thank you, Paul. Thank you, folks. So we'll see everybody in San Francisco. Okay, bye.
Thank you. Have fun at the conference. Bye.